Today I am going to explain on the transistor as a switch, its working and theory behind that. Transistor, you can use NPN transistor 2N3904 or BC547. So those transistors can function as electronic switch by controlling the flow of current between collector and emitter. This is collector, this is emitter. By controlling the flow of current between collector and emitter terminals using a small base current at the base terminal, the transistor can be used as a switch. So the controlling of flow of current from collector to emitter using the base current. So it works in two state, off state and on state. Off state, it is also called as a cutoff region, and in on state it works in a saturation region. In off state, when the base emitter voltage between base and emitter, when this voltage is less than 0.7 volts, between base and emitter, if the voltage is less than 0.7 volts, then the transistor is in off condition. There is no conduction. Then the transistor acts as an open switch. So in on state, that is saturation region, when base emitter voltage is more than 0.7 volts, between base and emitter, if it is more than 0.7 volts, transistor turns on. When transistor turns on, it acts as a closed switch. So when it acts as a closed switch, current starts flowing from collector to emitter. So the circuit completes, and if you are connecting LED to the collector terminal, then the LED turns on. So the transistor, it is like a controlled switch. A small base current allows larger collector current to flow from collector to emitter path. So in cutoff region, there is no base current. Transistor is in off condition. And in saturation region, the base current is present and transistor is in on condition. The LED connected to the collector terminal turns on. And in active region, the active region is not used in a transistor as a switch circuit. So active region is not at all used. Only the two regions are used, cutoff region and saturation region. So this is the circuit diagram for transistor as a switch. So the video I have already done on this using a Proteus, how the transistor acts as a switch. So here we are applying the base voltage using the potentiometer and DC supply, and here we have connected one LED, and this is the output voltage applied between collector and emitter. So using this circuit, the transistor acts as a switch, and that video you can refer. And the hardware circuit is this only. Here we are connecting one power supply, and output side also one power supply, and 1 kilo ohm resistor to the base and 470 ohm resistor at the collector. Whenever the base voltage is applied, base emitter junction is forward biased, transistor acts as a closed switch, LED turns on. When there is no base voltage, when it is less than 0.7 volts, the base emitter junction is not forward biased properly, and the transistor is in off state. When transistor is in off state, LED turns off. This is the graph between base emitter VC versus IC, keeping IV output characteristics of a transistor, VC versus IC, keeping base current constant. And you can see the graph here. The portion, the region before this is called as a saturation region, and the region below this dotted line, this is a cutoff region. In cutoff region, transistor is in off state. In saturation, transistor is in on state. From here to here, this dotted line, it is an active state. In active state, transistor acts as an amplifier. So in the transistor output characteristics graph, we have shown P max here. It represents the maximum power dissipation limit of the transistor. So it is the region where the product of IC and VC reaches the maximum permissible value before damaging the transistor. So from this point to this point, transistor is in safe condition. So it will allows the maximum dissipation of the power, that is P max. So the Pmax is always marked in the active region. So following the downward slope, this dashed line. So it separates the safe operating point from the damage zone. From here to here, you can make the transistor to work in a active region and acts as an amplifier. This is a safe region and there is no damage for the transistor. If the transistor operates beyond this line, the excessive heat may generate and it leads to the thermal breakdown. So that is about the breakdown of the thermal damage of the transistor. This is all about transistor as a switch.